Today we're looking at notes II-1, Calculus Prep Day 1. So in Roman numeral 1, we will be refreshing average rate of change. Remember we discussed this at the beginning of the year when we discussed both average rate of change and instantaneous rate of change. So this is just a quick refresher. So find the average rate of change of the given function on the given interval. So remember that average rate of change is really just slope, okay? On the given interval, remember the interval that's given is talking about x values. So it's domain, it's left to right. So in problem number 1, f of x equals 3x plus 8, where your given interval, or your domain, your x values, your left boundary and your right boundary, are 0 to 3. So first we are going to determine f of 0 equals 3 times 0 plus 8. So therefore we get the coordinate 0, comma, this would be 8. Okay, and then determining f of 3, that would equal 3 times 3 plus 8, so 9 plus 8, so we would have the coordinate 3, comma, 17. So remember to find the slope between 2 points. You do change in y over change in x, and that equals, let's go ahead and do 17 minus 8. Therefore, since we did 17 minus 8, we'll do 3 minus 0, we must. So 17 minus 8 is 9. So 9 over 3, which equals 3. So our average rate of change for this function on this interval is 3. All right, Roman numeral 2, even and odd functions. So an even function is symmetrical across the y-axis. For example, look at this quadratic graph. Okay, so this is a quadratic graph that, because it has only been shifted down and not left or right, this graph is still symmetrical across the y-axis. So I drew in the graph, but I also drew these pink points, which you see if you would fold over the y-axis would lay on top of each other, as well as these blue points, which also if you fold this graph over the y-axis, these two blue points would lie on top of each other. So an even function can be verified algebraically instead of graphically by proving f of negative x equals f of x. So this means if you plug in negative x everywhere you see x, if what you get out, if your output is the original given function, then that function is an even function. And when graphed, it should be symmetrical about the y-axis. An odd function is symmetrical across the origin. So I know it sounds so weird to say something symmetrical across the origin. You need to think of it as a double reflection. So that means you take your graph and you fold it over the y-axis, you reflect over the y, and then you fold over the x. Or you could go over the x first and then the y. It doesn't matter the order, but you have to do the double reflection. Fold over both the x and the y-axis. Okay, so for example, graphically, I want you to see this. So this is a cubic graph. Okay, you can see, hopefully you can visualize, if you take this graph and first fold it over the y-axis, this pink point would end up somewhere here. And then if you fold it over the x-axis after that, the pink point would end up here. So likewise, this blue point, we can do it either x first or y first, doesn't matter. If you fold over the y-axis first, would end up about here. But if you fold the graph over the x-axis, then the point would end up here. So essentially, any point on the right here will end up on the left here. Now, it will change position, so this point here that is on the right will fold to the left but then fold up, but just be aware that's how that reflection looks. So it can be, an odd function can be verified algebraically by proving that f of negative x equals negative f of x. So in other words, plug in negative x everywhere you see x and change the sign on every term of the original given function. So term is underlined, okay, because sometimes it's difficult to tell terms apart, okay? So we're going to talk about that as we go throughout the lesson. So on this section here, determine whether the function is even, odd, or neither. Then describe the symmetry. Okay, so on question number 1, f of x equals x squared minus x to the 4th. So I'm assuming, because of the exponents that I see, that I'm going to have an even function, but that's not necessarily the case. There are quadratics that are not even by definition here. Okay, if I had a quadratic that was shifted left or right, it would not be even because it wouldn't be a reflection over the y-axis. So we must use algebra to determine. So first step when determining is plug in negative x everywhere I see x. So it would look like this. Oops, forgot my negative there. Negative x squared minus, plug in negative x to the 4th. So f of negative x equals, here when I square that negative x, going to become x squared, and here minus drags down, and when I raise to the 4th power this negative x, it will become positive x to the 4th. So you'll notice when I plug in negative x everywhere I see x, what do I get? Look at my answer. Look at my result. My result is surely the given function. This is the given function. Can't you tell these match? Okay, so what does that mean? That means that I have an even function because my result was the original given function. So here I would write even. Even function, and it said to describe the symmetry. So even, and we would say y-axis symmetry. So if I graph this graph in my calculator or by hand, it should be a reflection. There should be a symmetry over the y-axis. Okay, number 2. So same initial setup. F of negative x equals 4, plug in negative x, square root 2 minus, plug in negative x squared. Okay, so f of negative x equals, and then this would be negative 4x, and then square root of 2 minus x squared. Okay, so that's all I can do. All right, this is simplified as much as possible here. And I'm looking at my result, and I'm looking at my original. So notice if this function is even, my result will be the original. Is that the case here? No. Okay, if this function is odd, my result will be negative f of x. That means change the sign on every term. Well, how many terms did I have here in the original function? This is only one term. So the only thing that negative f of x means is that this term turns negative. Did this term turn negative? Yes, it sure did. So that means this is an odd function and origin symmetry. Okay. Couple more. So g of negative x equals negative x cubed plus 1. So this becomes g of negative x equals, this would remain negative x cubed plus 1. So here's the deal. Look at your result. My result is definitely not the original. That's easy. Definitely not even. Okay. Did the sign change on every single term? On this problem, it's a lot easier to see the terms. On this one, it's difficult to see sometimes that that's just one term, and the only thing that needs to change here is the sign out in front. Okay, on this, it's clear that I have two terms. Did the sign change on both terms? No, the sign only changed on this term, not on this term. So therefore, this is neither, oh, I keep wanting to use the purple. This is neither even nor odd. Neither. Okay. So here, and I'll even write sign did not change. Okay, so the sign changed on this one, but sign did not change on this one. So sign changed, sign did not change on that one. Okay, so f of negative x equals negative x raised to the 5th minus 2 times negative x raised to the 4th plus negative x. I know it looks so wrong, but we'll keep it like that. Okay, so f of negative x equals, odd power means we will remain negative. That term will remain negative. Here you're going to have negative 2 times, this will become positive x to the 4th. Okay, and then here, of course, that'll just be minus x, whoopsies, minus x minus 2. Okay, so let's analyze. Is this the exact same as the original given? Nope. Okay, did the sign change on every single term? Nope. So this is another situation where neither even nor odd. Hopefully you're getting the hang of this. I love this stuff. Okay, so last example here, number 5. F of negative x equals negative 3 negative x raised to the 4/5. Okay, so remember what that 4/5 power means. So I'm going to come down. F of negative x equals negative 3. It's only the negative x that's raised to the 4/5, not the 3. The 3 has its own exponent implied of 1. Okay, so here we're going to have the 5th root of negative x to the 4th. Okay, so in other words, f of negative x equals negative 3 times the 5th root of x to the 4th, correct? Even power, this will turn positive. Okay, so if you convert back, just so you can see how it's changed based on the original problem, this looks like negative 3 x to the 4/5. Okay, so when we convert back to a rational exponent, all right, you can clearly see that the answer is the original given problem. So therefore, this is an even function that has y-axis symmetry.